this computer. So we're finding the formula now of different shapes. Some of it's going to be pretty much the same old, just applying what we've learned a different way. Some of it's going to be a little bit different here. But starting off here, when we have a cylinder, that's just like a soup can, right? Like a cylinder is like a soup can, right? Has the two circles, top and bottom, and then it's just a rectangle that's kind of rolled up. So if you remember, we talked about like the nets about things. This is the net of a cylinder right here. You have the top part of the can, the bottom part of the can, and then the circular part of the can, remember, it's just a rectangle that's rolled up, right? You take a piece of paper, goes from a rectangle to a cylinder. So if I want to find the area of a cylinder, all I need to do is find the area of the two circles, the top and the bottom, and then find the area between them. This thing, right? The stuff that's however tall this is, that's how much soup you can fit in your can. It's just a rectangle. So we know how to find the area of circles. We know how to find the area of rectangles. That's simple enough. Now, does anyone know what a circumference is? So circumference there, yeah, it's around the circle, right? We talk about circumference. Circumference is all of this stuff here, right? Or it's the length of the rectangle. Notice how it says C here? That's technically the C there, but like it shouldn't factor too much here. And then the width is going to be the height of the cylinder as well. So just looking at these graphs here, right? So now we have a couple new letters. There's C, which is circumference. That's the thing that's all around. We know what the radius is. Try not to sneeze. And then, of course, we have the height here. So we'll be able to find that out. Next, we have the pyramid. We know what a pyramid looks like. It's just a pyramid. It's a 3D object. And the sides are triangles. We'll show you a picture right after. And they all meet at a certain point, at the top of the pyramid. It's called the apex. You ever hear the term apex predator? That just means it's at the top of the food chain, right? That's what apex means, top. So top of the pyramid is called the apex. Now, we don't need to worry about Pythagorean right now. We'll eventually learn that, but we don't need to worry about it right now. And then finally, we have a cone, right? We always talk about like drums. Like I always talk about drumsticks whenever I think about cones here, or snow cones. But this is really just like a pyramid, but instead of a square base, it's a circular base. This has its own special formula to be able to find it, which is this thing right here. So really, 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 really make note of this. I know it's very easy to hide. Like put a little box around it. Page 23 is important. It gives you some more formulas. So this right here is the formula for a pyramid. Now, there's three things here, right? We know what pi is. That's just the button on our calculator. We know what r is. That's the radius. What do we think s stands for? Yeah, it's the slant, right? S is the slant. That's this thing right here, right? It's the slant of this thing. It's a straight line, right? Like think about like a drumstick, like ice cream cone, right? It's just straight. Now I know there's like the bump and stuff on it. That's because it's a waffle cone. But if you ever have like those little water coolers with the triangle, with the cone cups, it's just a nice smooth straight line, right? So that's what the slant is. The r is the radius, the s is the slant, and then the h, that's not unfamiliar to us, is the height. And then finally, we have a sphere. A sphere is just a full circle. I left that at home. It's a ball, right? Think about like a baseball. That's a sphere. So this is the formula for the sphere as well. So make sure you make a note of that, exactly what that is. So those are two new formulas here. We have our cone and we have our sphere formula. Pyramid and cylinder is nothing new to us, which we'll see soon. So first off, we're going to start off with something we kind of been doing before. Anyone remember what type of shape this is called? Starts with a C. It is a compound shape. Right, so this is a compound shape, right? We can find the area, the surface area of really simple shapes When they're not simple shapes, we can't find it. So what do we do? What do I possibly do with this? Turn it into a simple shape, right? All of a sudden, this makes a little bit more sense, right? What do I have here? Rectangle and what else? Semicircles, right? Half circles. A semicircle is a half circle. Now, if I have two semicircles, if I have two half circles, what is that? What actually is that? It's just one full circle. That's exactly right. So if I want to just find the area of this, it's pretty simple. All I need to do is I just need to take the rectangle, add the two semicircles, which is also just one circle, and that gives me my surface area, right? That makes sense. So let's start doing that here. I can use my text, not blue. I don't like blue. Are you able to see if I type this big, Kimberly? It's okay to say no.
A little bit bigger.
A little bit bigger. How's that? Good. Okay. So let's figure out the rectangle first, right? So what's the, we know it's a rectangle. What's the area of a what's the formula for an area of a rectangle?
Area equals.
Yeah, length times width. Yeah. So area equals length times width. What's my length? 58.4 centimeters times the only other figure there is 112.6, right? Okay. So times centimeters. Then all I want to do is, so Kimberly, this is where I was going to show you something. So my calculator that you're going to see on my screen here is the same as yours. Mine's just an emulator, so it looks a little different, but the buttons are the exact same. They're in the same place. So if I take this 58.4 times 112.6, I equal them out, you're going to get something like this, right? Little fraction there. 58.4 times 112.6.
Okay. Do I have to press anything to get the fraction?
So like this?
Yeah.
Is that what yours looks like right now?
No, I'm just. And then.
And equals?
Oh, yeah.
So now technically fractions are a good thing, but sometimes you need the decimal. So you see this little button right here where my mouse is? Put that, the change button, changes it. Yeah, changes it from a mixed fraction to an improper one to a decimal.
Oh, definitely.
Yeah, it's fancy, right? So my answer here is going to be 6,000. Okay, I'm going to move this over. 6,575.84 centimeters squared. Cool. I've got my lovely rectangle.
So I got her.
Yes, yeah. So I've got my rectangle. Now I just need my. So there's two ways of doing this. I could find the area of each semicircle, which means how would I find the area of a semicircle? Let's imagine there was only one of them. How could I do that? Well, semicircle is how big of a circle is it? Half. So couldn't I just find half of a circle? Now, in this case, I have two of them, so we don't need to worry about that. But so I can just find the area of a full circle, which is the same thing as two semicircles, right? What's my formula to find the area of a semicircle? Oh, sorry, area to find of a circle,
Pi r squared.
Pi r squared. I don't have a pi symbol, so you're gonna have to deal with this. And pi r squared is just the same thing as pi times r, correct? Now, there's a complexity here. We need the r, we need the radius. There's no figures here. So we need to use what we know to find what we don't know. I'm just drawing the center of each semicircle there. How can I figure out the radius based on the information I have here?
Take the height of it and divide it by 2.
Right. Remember, the radius is just the thing I'm drawing in black here, right? It's half the length of a circle from the outside to the edge. I know how tall the whole circle is, so just cut that in half. So R in this case, so I'm just going to write this a little bit up here. So R is going to be 58.4 divided by 2, which is the same thing as 28.2. No, 29.2. Cool. I now have my radius. So pi times text. Pi times, oh shoot. What did I say? 29.2 times 29.2. Right? And it makes sense why I have 2 of them, right?
So we times those and then press pi.
So yeah, so what you're going to do is you're going to so 29.2 times 29.2, and then you times that, yeah, by pi. You'll have a little pi button, should be about right here.
Oh my goodness.
Right, so it should be about right here, right? And then you press equals, and you're gonna get this disaster, right? So what do we need to do? We change it.
Times pi.
Times pi, enter.
And change it.
Yeah, once you press enter, then you change it. You should get something like this at first.
26.716.
You betcha. So that's going to be my answer, right? So the area of my circle, because this is both the semicircles, the area of my circle is 2,678.65 centimeters squared. What's my last step?
Add them.
You betcha. Add them up. So I have the area of my rectangle plus the area of my 2 semicircles, which is just one circle, equals my surface area. So
Delete on this or no?
you can, there'll be a little on button on the top right.
Okay.
So all I do is I just take 6,575.84 and I add on the 2,678.65, and that's going to give me my surface area. Oh, sorry, surface area equals. And if I add those up, right, this is centimeters squared. I'll put the squared in a second. 6,575.84 plus 2,678.65 equals 9,254.49 centimeters squared.
So what made you do the typing in the numbers instead of like trying to write?
It's neater, isn't it? Yeah, yeah. I didn't know I could do it, to be honest with you, in the first day. So I tried to find a way where I could. Okay. So just to kind of like a refresher here, get our brains up and coming. Again, you have a shape, you have no idea what to do, break it into simple shapes, right? It's usually going to work. All right, we're all good to go. Can I move down? Austin, you're all good?
Yeah.
Gotcha. Perfect. All right. Now, two reasons this next question's harder. Number one, there ain't no picture. Number two, it's a new shape. So find the surface area of a cylinder that has a radius of 90 millimeters and a height of 330 millimeters. So I'm gonna just draw myself a nice lovely picture here. And it's pretty easy to draw a cylinder.
Oh, do you want us to draw?
Yeah. Why not?
Just do this, is it, never mind.
So to draw a cylinder, all I do is I do my little little oval type shape on the top, right? It's my lid. I draw two straight lines that go down. And then I just draw a nice little flat surface here. And boom, I have a soup can, right? I have my cylinder. That's what a cylinder is, it's a soup can. So that's one thing I've done is I have drawn my picture and then I'm going to label the dimensions, right? I'm going to label the dimensions. So how I do this? My height is 300. Okay. My height is 300 millimeters. And the radius of my circle, which means it starts in the center and moves to the edge, is 90 millimeters. Give me 1 second here. I remember today. Okay. Oops. Okay, so what is my formula to find a cylinder? Trick question. There isn't one. Cylinder is just two circles and a rectangle, right?
I was gonna say.
Yeah. So the SA of my cylinder is just the surface area of my cylinder is just circle, circle, circle plus rectangle, right? That's how I find it. The top circle, the bottom circle, and the rectangle that forms the can. That is how you find the area of a cylinder. It's just a composite shape made up of slightly different things. So first off, let's find the surface area of the circle. What's my formula there? You betcha. Yeah. So the area is equal to pi. This weird little thing I'm drawing is pi r squared. I'm going to skip a step for the sake of space, right? We know that r squared just means r times r. We know there's little invisible time symbols behind this. I'm just going to instantly fill out the next thing. So it's pi times what's my radius? 90.
This is like easy somewhere, but sometimes
It's easy. Like if I give you the shape, you can do it. It's when we have, it's a multiple step problem, right? So it's easier to make mistakes there. So, okay, I'm just gonna erase this to make this a little bit neater. This is, so why am I putting brackets here and then putting the 2 on the outside? Why am I doing that?
because you have to times it by itself.
Right. So there's a difference between what I have on the left and what I have on the right. What I have on the right is 90 millimeters squared. This is not telling you to square this. This just says I have an area of 90 millimeters. What I have on the left is taking 90 millimeters and timesing it by itself. So that's just something that's kind of important to make note of. Delete that. Okay. So if I times all this out, then pi times 90 is going to give me a big fat whopping
25,046.9.
holy crap, 25,446 point. No, I'm just gonna put 9 millimeters squared. 0.9 millimeters squared. Perfect. All right, boom. I have the surface area of a circle. Now I just need the surface area of a rectangle. Text. Okay. So we need, so SA of rectangle is equal to, how do I find that? Length times width, right? So we,
This will be 300 times 90.
it would not actually, because 90 is the radius. So we've encountered a problem here.
You have to find x.
We have to find the width of this. So remember, so what we know is we know the height of it. We know the height of it. We know the radius of it. Yeah, right. This is like a really tall soup
Well,
can.
wouldn't it just be the half of that?
Half of which? So right, I have the height, right?
Times,
If I unfold this piece of paper, my height is just this, right? But I need this, and it's in a circular.
but if it's 90, then wouldn't it be 90?
Well, the radius, that's the radius though, right? But that's not the,
Are we divided by 2?
ooh, so you're on the right track. We need to do something with that. So I'm about to give you a brand new formula, and I want you to go up to page 23 again. This. We need to find, it's called
The rectangle will be the circumference of the circle.
the circumference of the circle, you bet. We need to find the circumference of the circle. What the heck is a circumference?
It's the C.
In that, yes. The circumference, remember, this is height, right? This is height.
90 degrees.
The circumference is the distance the circle goes around, right?
Well, can't you just use one right there?
Well, can you bend a tape measure like that perfectly? So-
Use a piece of string and then hold it.
You could, but maybe you don't have it perfect. What if I'm trying to find the circumference of the sun? You know, there's no string long enough.
Then you just go to Google.
Well, they figured it out with math, but you're right. So, but does that make sense what circumference is? Circumference is the area around here, right? It's like the rim of it. So to find the circumference of a circle, you take 2, you take pi, r, 2 pi r. The circumference of a circle is 2 times pi times r.
So, well, so that's 90 millimeters, right?
Well, let's go into it. So everyone has that down? Well, let's go into it. So it's 2 times pi times r, right? So before I can find the width of it, I'm going to find. So I'm going to actually go to a different section here, and I'm going to find the circumference. Circumference. Circumference of what? The circle. So how do I find circumference? I just take circumference is just equal to 2 times pi times r. Right? So that's 2, this darn mouse, times pi. What's my radius, Kimberly? 90 millimeters, you betcha. Now, so my answer here.
You have to do twice. There's a 2.
Well, oh, but it's the big 2, right? This means it's just the number 2 times in it.
Oh, I thought you were doing this other formula.
Oh, I see what you see. Now, we're not finding the area of it, right? So this is different. Like, so the circumference is different than the area, right? The area is going to give us millimeters squared. It's a measurement of area. It covers this much space. This is the length, right? The circumference is just a length around the circle. So it's 2 times pi times 90 millimeters. What's that going to give me? 565 point equals 565.49 millimeters. Just millimeters, not squared, right? We're not finding the area, we're finding the length. Well, a tiny shoe. Okay. So what do I do with this circumference now? The circumference is going to be what I'm about to highlight in blue. This is the circumference. What I'm drawing in blue up there. Right? So this, imagine this is a nice perfect sphere. This is the circumference, right? I unfurl it out, my rectangle. That is my other unit of measurement here, right? So this 565 millimeters, that is my width times the circumference, or times 565.49 millimeters. It makes sense why I'm putting this in, right? You have to break it down to its base shape. So I times these together, and I'm going to end up, because now I'm finding the area of the rectangle. So now I'm times them together. So I get 169,647. Oh. What did I do? Millimeters equals 169,647 millimeters squared. Okay. Am I done? Nope. What do I need to do next? Sorry? Add them. Add what?
The surface area of up there and down.
Yeah, the surface area of the circle.
Rectangle and circles.
Yeah, the rectangle and the circles, plural, right? Man, always simplify. Write down what you need to do in like plain English first. Oh, I just need to take the circles and the rectangle, add them together. Is the circumference used anymore? Is this thing here, the circumference, used anymore? It's not. I only use the circumference to find the area of my rectangle. So, if my surface area of the cylinder is equal to circle plus rectangle. Oh, all I need to do is just bump those values in, right? So that is going to be, you do not need to write this down, by the way. I know this takes a while. I'm just doing this just to show you, but it's 2469 millimeters squared plus, sorry, 25466.9 mill. You not need to write this. I understand it's a lot. Plus 169,647 millimeters squared. You're adding all these bad boys up. And that whole thing is equaled out to plus 25446.9. 220,540.8 millimeters squared. Okay, that is the surface area.
Add 2 circles.
I did it, didn't I add 2 circles here?
I did.
Oh, yes, a common mistake though, right? That's why it's really helpful to kind of like write out the formula like this. It's just cylinder is equal to circle plus rectangle. Okay. Let's keep chucking away here. I want to do 2 more to start out. Right, what do I got here? Pyramid, right? What is a pyramid made of? Look at those. It's made of 2 basic shapes.
Triangle and a square.
How many of each?
3, 4, and 1. I mean, 4 and 1.
4 triangles, 1 square. So we want to make this we want to make a nice simple equation here. SA of pyramid, surface area of pyramid is equal to 4 triangles plus 1 square. Right? That makes sense why there's 4, right? A pyramid just has triangular base sides.
Okay, so it would be half each.
Ooh, well, let's find out. Okay, so that's my surface area here, right? So let's find the area of my triangle first. So triangle is what formula?
1 and 2.
So a half, yeah.
Isn't it base times height?
BH. Yep, BH, you're right. Yep, base and height. So that's just a half times, I'll write the half there in a second.
So if we do that, then we have to do that 4 times to find the surface area, right? Add it 4 times.
We'll need to eventually, yes. So in this case, it's a lot of steps, right? So keeping organized is crucial to these types of problems. So it's a half, my base is 24 meters times my height, which is?
Is it 16?
It's 16 meters, you betcha, yeah.
It's just a weird spot.
I know, yeah, we have to kind of look at these graphs carefully. So if I bump these together, I'm gonna end up getting 192 meters squared. Okay, cool. That's the area of how many triangles? 1. It's 1 triangle, right? I found the area of 1 triangle.
Add that 4 times, unless.
You could, so you could do that. If you wanted to then do times 4 and put whatever there, you can do that. I'm just gonna stick with my lovely formula up here. So I do it all at the end, but you could do that. That's fine. There's multiple ways of doing the problems now. Okay, now I'm gonna find the area of my rectangle. Area of a rectangle is just length time, ooh, sorry, not rectangle. Actually, yeah. Let's say rectangle equals just length times width, right? What's my length?
Length would be 16.
Isn't 16 the height of the triangle? That's how high the pyramid goes up.
Oh, 24?
24 times, what's my width?
24.
24 meters. So we actually have a square. For once in the class, we have a square. 24 times 24 should give me 576 meters square. Okay. And then all I need to do is just go back to that formula I wrote at the very start, right? Surface area of my pyramid is just 4 triangles plus, yep,
Oh,
you good? No, where'd I get, oh, this?
oh, I was doing the wrong one. You were doing the right. I thought that was a triangle.
There's a
I did
triangle.
square.
This is the triangle, right?
24 and 24 is a square, so a square is a rectangle?
Square is a rectangle, yep. Yeah,
Well, just the formula is the same.
it's technically the same thing, yeah. All right, so there's 2 ways you could do this. You could just do, if I have 4 triangles, it's just, 192 plus 192 plus 192 plus 192. You can also do it just 4 times 192 meters squared. Plus, well, 1 square is just 576. Does it make sense where all of a sudden I'm times and stuff here? You can do it either way. If you want to add it, you can do that. Frankly, you don't even have to show this step as long as I see this step. I can just assume you did this in your calculator because this sucks to write.
Where's all the answers?
Sorry?
Where's all the answers?
Ooh, I made this myself. I do have the answers for most of it.
I mean, for the, I didn't do the pages, but the pages.
I have them on a piece of paper. Yeah, I'll start filtering those out. So if I start powering through these, so that's going to be what, 768 plus 576, 1,344 meters squared. Boom, that's my answer. It's a final answer. What am I going to do with it? I'm going to circle it. Cool, done. Oh, sorry. I still didn't hear you. Beside this?
I think it's the X, I like a times.
Oh, sorry, that's supposed to be a times. Apologies. That's a way of doing it on a computer, the little star there. Let me fix that. Sorry, thanks for catching that. We don't need to, I can just write an X here.
So. Fine.
Okay. Right, we're gonna do one more, which is a cone. So question 4, find the surface area of a cone that has a radius of 12 feet and a slant height of 15 feet. So, oh, sure. Oh, go up. Oh.
Yeah.
Okay. So if I want to find the surface area of a cone, there's a radius of 12 feet. and a slant height of 15 feet. I am just going to take, first off, I'm going to draw myself a cone, right? Oh gosh, that's an awful drawing. Yes. I'm gonna draw myself a cone. Luckily, we have a nice model. So it's really just an oval or like basically a circle with two slanted lines going down to meet the apex. Whoops. Okay. I now have my cone, and I know that I have the center of it. I know it's not a lovely drawing. I don't, this is the unfortunate part of having a mouse. There's no line button. That's why I gave these guys a nice one below it. So does anyone know what this little like dotted line I'm doing means?
The length? The height?
Well, that's what it is, but it means something in drawings.
That's beginning and the end?
No, good guesses. It just basically means it's like it's not like a part of the structure itself. Like it's just like an invisible guiding
Oh, I
line.
thought you meant like, well, yeah.
Oh, yeah.
But-
I know it's a very broad question, right?
Special name, so I'm just thinking.
Yeah. So in this case, I need to then label it, right? So where do I put the 12? Austin, where do I put the 12?
At the circle,
Where?
in the middle.
In the middle, right? It's the radius. So 12 millimeters, right? And then where do I put the 15, Hannah? The slant.
Side.
It's the side one, right? 15 millimeters. Oh, sorry, 15 feet. 15 feet, not millimeters. So we need a third measurement here, right? Which is the pure height of it. Now, we could figure this out using something called Pythagoras theorem. We're going to learn that later. So for now, I'm just going to give you the value, which is going to be bear with me 1 second. Oops. So right now, the height is 9 feet. You'll eventually be able to figure that out for yourself. You might be able to already, but I don't care about Pythagoras right now. I just care about we find the surface area of this. So the
So it's 90 feet?
9 feet. The height is 9 feet.
How do you know if it says 15?
No. The slant is 15, but the pure
Oh,
height,
slant
the
is
slant is 15. Yeah. We'll do Pythagoras later. It's not the goal right now. We don't want to deal with solving equations.
15. Oh.
Okay. Now, what is my formula to find the surface area of a cone?
E equals pi r squared,
Ooh,
or rs.
RS, right?
I didn't, oh, yeah.
No worry. No, it's fine. So the surface area of my cone is equal to pi times r times s. Pi times r times s, right? It's pi times r times s. So let's substitute those values in. Why don't we? Oops. Anna, what is my r? 12. 12 feet. Yep. Times Aiden, what's my s?
Slant,
Slant, which is
15.
15 feet, right? Cool. Now I just bump this into my calculator. 12 times 15 times pi is going to give me 565.49 feet squared. Simple enough. So in this case, I didn't actually need the height. I just wanted to show you that if we don't have the height, there's ways to find it. All right. I want you guys to try number 5 on yourself. But before you do that, Austin, what is my radius for number 5?
Number 5.
Yeah.
Four point eight.
4.8, right? It's 4.8, not 9.6. The radius is half of this length. So you have to half this thing.
Where's Austin?
Hidden behind a chair,
Yeah.
right? So does it make sense where we pulled 4 from 8 from? It is half of the length of this. The radius is only half of the circle. I know the length of the full circle. Chop it in half, right? So I'll give you guys a minute and a half to work on that. While I pause this. Pause recording.
I'm still doing the first one.
Oh,
I was just busy.
yeah, I lied to you. We're just gonna keep going. We got 2 more questions, then we're good. All right, everyone good? No one's saying no. I'm moving down. Oh, you're on 6? Okay. So we have a ball. What type of shape is a ball? A sphere, and it has a surface area of approximately 99,000. Oh, shoot. 99,000 centimeters squared. We're going to skip number 6 for now because this deals into equations we don't need. We'll come back to it eventually. Well, actually, we probably won't. I'm sorry. I changed the order of how we do stuff, so it's kind of affected a little bit. Okay. So what I have now is, this is similar to some stuff we've done in the past where we have 2 3D shapes that are stacked on top of each other, and we're finding the surface area. Now, so that's first off, it's 3D shapes, so it's a little bit harder. 2, there's 2 of them. That makes it a little bit more difficult. And then 3, what's the third thing that makes this a little bit more difficult?
Well, circle, rectangle, and we just can just do one formula for the cylinder and for the cylinder, I mean,
We don't know
the
the height of
cone
the.
and the.
Well, we don't know, we don't need the height of the cone,
You
thankfully.
just have to tell us.
So here's the issue, right? So here's the issue. These are connected right here. So I need to, one, exclude this from the area of the cone, right? But I also need to exclude it from the area of the top part of the cylinder. So let's break this into, again, English. How would I find this? So the surface area of this whole thing is going to be equal to, it's a cylinder plus a cone, right? It's a cylinder plus the cone, but I need to take something away from it, right?
Well, can't you just do the surface area of the cone first? It'd be like so much easier.
Well, we can do that first, but we'll get there. So it's the cylinder and the cone being added together, right? But I need to take something away from it.
The circumference of the cone.
Not the circumference of the cone, the little area here, right? This little area here, they're connected there. I need to take that away. How many times? Well, remember this little, this little part I'm filling in here. This little part is both, you calculate this on the surface area of the cone and the cylinder. I need to take that away, not once, but twice. So cylinder plus the cone minus little circle minus little circle. Right? That makes sense in English. Again, you always break it down as simple as you can, right? Okay. I'm just going to start with the cone because it's right there. Surface area of a cone is equal to what formula? What page would you go and check?
The cylinder,
For this, for a area of a cylinder, right?
that is S.
Pick-
Pi.
Yeah, so on page 23, the area of my cylinder is equal to pi r squared. Sorry, not pi r squared, pi r s. Pi r s.
Oh, is it an S?
S is slant there, yeah.
Okay.
A little square is going to be that tiny 2 thing, right? A little square would be like this.
I did that wrong.
Oh.
The cylinder?
So for the cone then, so it's pi
R?
Sorry.
S?
pi r s. S is the slant. S is the slant. So in this case, I know what pi is. That's going to be times r. What's my radius of this cone? 1 point. Why is it 1.7, not 3.4?
Radius is half.
Radius is half that, right? Radius is only half the circle. So it's 1.7 centimeters times it by the slant, which is this little cone, right? 8.6 centimeters. So pi. So if I bump all those in together, so 8.6 times 1.7 times pi. It's going to give me 45.93 centimeters squared.
That's not just 8.6.
Sorry,
What is 8.6?
8.6 is the slant. Stop in there. Okay, so cool. I've done my cone. Cone, check, done. Let's go into the cylinder now. Surface area, cylinder. How do I find the surface area of a cylinder? What two shapes do I need? What all shapes do I need to put in together?
A rectangle and 2 circles.
Rectangle plus circle, right? So we have a question within a question. It's questionception. Okay, so I'm just going to do the rectangle. And it's a question within a question within a question because I know the length of it, which is 9.3 centimeters, but I don't know the width of it, right? I need to know the thing I'm drawing in red. The thing I'm drawing in red, this is technically the width of the rectangle, right? And does it make sense why this is the width of the rectangle?
Yeah.
Because if we unfold it, it turns into a rectangle. So what do we call this? Circumference, you betcha. So I need to find the circumference before I can find the width. So it's a very hard problem. So the circumference is equal to circumference is equal to 2 times pi times r. So 2 times pi times r, that's 2 times pi, my radius. My radius of what? What am I finding the area of?
Cylinder.
The cylinder, right? So what would my radius be then?
5.6.
Would it be?
Wouldn't it be? So this is the length of the whole cylinder, right? Radius is half of that. So this is going to be a 5.6 centimeters. I took that 11.2 and I chopped it in half. It makes sense where I got this from, right? So if I times that all together, 2 times 5.6 times pi, I'm sorry, I know my thing's in your way. Times those together, I get 35.19 centimeters squared. And so Hannah, what do I do with this 35.19 centimeters? Sorry, not squared, just regular. What do I do with that 35.19? Goes in the rectangle, right? You betcha. Good work. 30. So now I go back to my rectangle, right? I know my rectangle now is 9.3 centimeters tall and 35.19 centimeters wide. So the rectangle is equal to 9.3 times 35.19 is equal to 327.27 centimeters squared. Cool. I now have half of the puzzle with the cylinder, right? Now there's also the circle. I know. Right? It's simple math, but it's made to be complex. That's why we need to always keep ourselves organized and everything.
A square root of 10 to 5.
So circle equal, sorry, so the area of a circle is just going to be pi r squared, right? So area of a circle is pi r squared. My radius is what? What's my radius, Hannah?
5.6.
You're not Hannah, but yes, it's 5.6 centimeters.
Oh, shit, sorry.
No, no worries, no worries. So it's 5.6 centimeters. And remember, I'm squaring this whole thing, so I have it in brackets. Because if you just put it right here, you're not gonna know that you're squaring the whole thing. So to punch this in my calculator, it is 5.6 times 5.6 times pi.
Square in here, is that still? Right. Well,
Like, do you think this thing right here?
I'm not calculating.
Oh, like you're looking at you're looking at this button?
Yeah.
That button would square it. You just have to be careful with how you kind of put it in. Because you don't want to do pi times the radius and then square that. You want to do just the radius squared, then times it by pi. But that would work. So you could do it like this. So you could do 5.6 squared equals then times pi. That works. But yeah,
Sorry, that's the same.
not all calculators are going to do. This is a scientific calculator. If you were to do it on your phone, it would not work that same way though.
I did not hear it, but I thought it's wrong.
Oh, like you did, like pi times 5.6 squared?
Yeah.
So, oh yeah, so that's why it does the order of operations. Ooh, load. So if I were to do that, yeah, so if I do,
So you'll get this in,
I do 5 times 5.6. So on this calculator, it will work. But what some calculators will look at it is some calculators read it like this. They're saying, oh, you're taking pi, where's my pi? You're taking pi times 5.6, and then you're squaring that. So some calculators are going to be a little bit different with how they read it. That's why it's really important to break it down step by step. So I personally like just doing 5.6 times 5.6 because every calculator is a little different. But my answer here is going to be 98.52 centimeters squared. Okay, am I done? Do I just add these together and move on?
added 2 times,
Well, I added 2 times.
because there's 2 circles.
There's 2 circles. So I need to go back, right? So my surface area of my cylinder is the rectangle and the circle. So now I just need to bring it all back together, right?
Just add them all together.
Yeah, you're right. So surface area of my cylinder is equal to rectangle, which is 327.27 centimeters squared, plus 2 circles, 98.52 centimeters. Ooh. Plus 98.52 centimeters. I add all those up. $327.27. Add all these up, I get a total surface area of 524.31 centimeters, and it's big enough for everybody, right? We're all able to read this. I'm just gonna little box this away just so it's kind of out of the way. Okay. So remember, this is why a lot of people at this point would think that, oh, I just add these 2 up and I'm done. It's cone and cylinder, done. Because we spent so long on the problem at this point, it's easy to forget what you need to do. That's why at the very top, it's really helpful to write it down in plain English, the goal. The goal of this is we're taking a cylinder.
What about the 45 transaction?
For,
Oh,
well, we'll get there. So that's what I'm talking about. So remember, it's the cylinder plus the cone, but we got to take away this little circle here, right? We need to we've spent so long on this problem, it's easy to forget that. So that's why I always make a nice simple equation at the start. You can refer back to it. You see I'm interacting with it, check. I see I'm still missing stuff. So let's go, let's figure that out then. So now I need to figure out the area of what? The little circle, yeah. How am I gonna do that? Oh gosh, surface area. Little circle equals what? I know the formula for the area of a circle. It's just pi r squared. I'm just gonna write that in really quickly. I know what that is, but what is the radius of it? 1.7, right? Half this little thing. It's gone back there.
I thought you did that with.
You're right. I found the area of the cone, but now I need to take away just this one part of it. So I need to do that. I need to find just the area of this circle. So I'm just going to do that. So it's pi times 1.7 centimeters times 1.7 centimeters. And so when I pump that in my calculator, that gives me 9.08 centimeters squared. Okay. And with that, I'll give you a second.
Just add that.
So with that, we are pretty much done. I have all the components that I need for my main formula, right? So it's cylinder plus cone minus little circle minus little circle. Okay. So the total surface area is equal to cylinder plus cone minus circle minus circle. Sorry, little circle. I'm just going to put LC. Right? LC, little circle. Yeah. Saves us some time writing. Now, I am not going to write all of these numbers here. I'm just going to put the answer to the next thing. You've shown your workings there. If you write that, cool. Good to go. So I'm just going to add these up. 45.93. And I want you to do it as well on your own, and we'll just make sure that it got right there, that was done correctly. Because now we have a lot of big numbers there. So take this time to practice it. Try getting the answer on your own with the numbers we've come up with. There's just a few ways you could, there's a few common errors that could be made here. Don't yell it out. Just give it everyone 30 seconds. Okay. What did everyone get? Okay. We'll make sure everyone has it.
5.20.
Is that what everyone has? So You got which? 355? Okay, let's take a look then. I think I know what you did. So, this is why I wanted everyone to give it a shot, because it's a really complex problem. So,
I didn't know what I was adding.
I know that's the issue, right? So this is why it's important to keep organized. So let's first off, this is the correct answer, but I want to scroll up here. So we are doing the cylinder plus the cone plus the circle plus the circle. So what I bet some of you did was you got this right. You did the cone, but you added the rectangle and not the cylinder. We do not add these in. Oh, no, oh, shoot. Okay, whatever, it's left there. I didn't want to do that. So we don't actually add these up and this, remember, because we got this number by adding these two things here, right? So it's the 45.93 plus the 524. Then you subtract these little circles here. So Hannah, what I think you did, Hannah, was you did the cone plus the rectangle minus the circles. Very common mistake, right? You'd get like 9 out of 10 if you did that, because you did all the hard work. You just made a very simple mathematical error, and that's okay. So everything that I'm underlined in red is what you would add, or what you would add or subtract. Again, if you frankly got to this point, you'd basically get full marks. Like, I'd understand you know how to solve it. You just made a really simple error. People make small errors like that. I don't care about that. You've shown me you could work through the problem, though. That's the big thing. Okay. That was a brutal one, right? That was a brutal question, right?
Yeah.
It would have been okay if we didn't have to take this part away, but we did.
I didn't get most of it. But I wrote it down now.
Wait, do you need to write it down still?
No, I already did.
Okay.
I just don't get most of it, but I have it written down, so I'll get a picture.
Yeah. So like, this is, something we kind of done here together. What I want you guys to now do, take the time to do some of these practice questions here. Now, I just want to go through and find any hypotenuses I need to give you guys. Okay, we're good there. So really quickly, go to page 33. Go to page 33 on your notes really quickly. I promise this will only take a couple seconds. Again, I'm not going to make you memorize the names of shapes. That's fine. So number 8 on page 33, a pentagonal based pyramid, 5 sides. Literally just write that, 5 sides. There's 5 triangular sides and the bottom here. And then what I want you to do is, oh shoot, yeah. It's technically this, isn't it? Wait, no. Sorry, give me a second. Give me a second here. How did I want to do this? Yes, okay. There we go. So then draw these in. These are 5 triangles. This is what makes that up. So then there's just 5 triangles in the base. It's a mean question, I'll be honest with you. So don't worry if you struggle on this one. But this is,
Do this one?
if you get to it, it goes really hard eventually, but so this is a 5-sided, so there's 5 triangle sides, and then there's 5 little triangles that's how you'd figure this out. Normally we have squares on the bottom. This one's 5 little triangles. So I just wanted to make sure you guys had a note of that. 18. And the height of that is gonna be bear with me 1 second, because I need to give you that. Oh my gosh, there we go. Oh yeah, here we go. And so the height of each of these triangles is gonna be what was it? Oh yeah, that's what it was. .58. Do not worry about question 9. You can cancel that one out. Yeah, okay. You know what? Just ignore question 8 and 9. Just get rid of it. Straight up, don't worry about them. So just don't even do question 8 or 9. You can skip them. Okay, I'll give you guys some time to work on those. Oh shoot, recording.